Hi everyone, today we're going to talk about the mole concept. Mole is one of the main concepts of chemistry. Chemical reactions occur between large number of particles, which are atoms, molecules or ions. Atoms, molecules or ions are small particles, very tiny particles. The unit is mole, and it's symbolized by N. Mole concept and mole unit symbolized by N, and it is one of the basic units in the international system according to IUPAC system. The mole defined as the quantity of material containing the same number of particles, molecules, atoms or ions containing 12 grams of carbon isotope. We use the carbon here described to the mass of the atoms. There is an important number here, Avogadro's number. It is 6.023 times 10 to power 23. It is equal to 1 mole. We said that atoms, molecules and ions are very small particles, and it is not possible to number them easily, and we have to use we have to use a unit for them. Mole is a special unit to describe the number of particles, like dozen. Dozen is equal to 12. Like the dozen, mole is equal to this number. Avogadro's number is also shown with the Na. Na is the symbol of Avogadro. N is number of, A is Avogadro, number of Avogadro. We have to notice that the mole is actual amount of the matter, is not mass. We're not talking about here mass, we're talking about the amount of matter here. That's why we use this number to describe the amount of atoms, molecules or ions. There are some examples to show the mole concept here. 1 mole of carbon, we said that 12 grams exactly. 1 mole of copper is 63.5 grams. These amounts, 63.5 and 12, are given in the periodic table as the atomic masses, gram atomic masses. But these are exactly for the 1 carbon atom. It's equal to 12 AMU, atomic mass unit, but for 1 mole, it's equal to 12 grams for the carbon, and for the copper, 1 mole of copper atom is equal to 63.5 grams. We have a formula to calculate the mole number from the mass and molar mass. Mass and mole is equal to mass, it's symbolized by small m. Molar mass is symbolized by big M. Molar mass also known as the gram atomic mass and gram molar mass. And gram atomic mass, which is given in the periodic table for each element. It is the total number of protons and neutrons for the atom. For the molecules, molar mass is equal to sum of the atomic masses of the element which is in the molecule. There is exercise 117. Perform the following conversions. For the first one, we have the mass and we have the molar mass or atomic mass, and we don't know mole. To calculate the mole, firstly we have to write the formula. N is equal to m over small m over big M. Small m is mass and big M is molar mass. Mass is given here 3.2, and the molar mass also given 64 grams per mole is equal to 0.05 mole copper we have. For the second one, mole number is given 0.2 mole silver is equal to how many grams of silver, and the molar mass of silver also given. We know the formula which is used for the calculation of mole, m over big M. From here we can arrange the formula according to the mass to calculate mass. Mass is equal to M time big M, mole time molar mass. From here, mole is given 0.2 times molar mass also given 108. From here, the answer is 21.6 grams of silver we have. Molar mass. Molar mass is the mass of 1 mole of a compound in gram unit. Molar mass of matter, total relativistic masses of atoms which make up matter. For example, in the water we have 2 hydrogens and 1 oxygen atoms, 2 hydrogen and 1 oxygen atoms in the water, and the atomic mass of hydrogen is 1, and 2 times 1 plus 1 times 1 oxygen we have, 1 times about 16. Totally, the molar mass of water is 18. We can see the calculation here, 15.9, and it is for 1 oxygen, and 2 times of hydrogen, about 1 and 1, and is equal to 18.0153 gram per mole. We can see more examples about the calculation of molar mass. Calculate the molar mass of methane gas, CH4. 1 carbon and 4 hydrogen we have in the methane gas. Mass of 1 mole of carbon is equal to 1 time 12, because 12 is the atomic mass of carbon. 1 time 12 is equal to 12 gram per mole. Mass of 4 moles of hydrogen, 4 times 1 is equal to 4. Totally, mass of 1 mole of methane is equal to 16 gram per mole. Another example, calculate the molar mass of sulfuric acid. 2 hydrogens we have, 1 sulfur, and 4 oxygens we have in the one of the sulfuric acid molecule. 2 times 1 is equal to 2, because the atomic mass of hydrogen is 1. We have 1 sulfur, 1 time of 32. 32 is the atomic mass of 1 sulfur atom. 1 times 32 is equal to 32 grams. 4 times oxygen we have, 4 times 16 is equal to 64 gram per mole, and totally the molar mass of sulfuric acid is equal to 98 gram per mole. There are more examples, and we can do one of them here. For example, juglone, we can do it. In the juglone molecule, we have 10 carbon, 10 times 10 times 12, 12 is atomic mass of carbon, plus 6 times hydrogen we have, hydrogen is 1, and 3 times oxygen, oxygen is 16, is equal to 120, 174 grams per mole. The molar mass of juglone is equal to 174 grams per mole. There is a relationship between the atomic mass, molar mass, mole, Avogadro's number. For example, 1 mole of water is equal to, in this number of molecule, and also is equal to 18 grams. Find out the mole numbers of the following compounds. For the first one, we have the mass of sulfur dioxide, and we have to calculate the molar mass of sulfur dioxide here, because we need molar mass to calculate the mole number, because in the question asked calculate the mole number of the compound. We have to calculate the molar mass of sulfur dioxide first. 1 sulfur we have, plus 2 oxygen we have, is equal to 64 gram per mole. Molar mass of sulfur dioxide is 64 gram per mole. And we know the mass is given in the question, and we know the molar mass now. And from here, the mole of the sulfur dioxide here, 0.5. For the second one, mass over molar mass, and we have to calculate the molar mass of the ammonia. One time nitrogen, nitrogen is 14, plus 3 times of hydrogen is equal to 17 gram per mole. And from here, we know the mass is given here, and the molar mass is 17. From here we can get the mole number of the ammonia, and it is equal to 2.